we'll introduce ourselves in a second, but just a heads up. I mean, I've been to quite a few talks. I got in late last night, quite a few talks about programming languages. And what I love about these conferences is how we learn from each other. So how these communities come together and kind of learn, share, and inspire each other. And I think this talk, which Andrea and I are giving, is very similar. It's on how Erlang and Elixir go in and inspire each other. So there are two programming languages which would not have been around today had they not been for each other. Had Erlang not been around, had Erlang not existed, Elixir wouldn't have been invented. And had Elixir not been around, I'm not sure Erlang would have been thriving as much as it does today. So they were created with different purposes in mind and resulting in very different use cases, programming approaches, and communities. And these are communities which have a lot to learn from each other. And kind of this learning and cross-pollination has to continue in order for both languages to survive, grow, and prosper and thrive. Because, as we kind of believe, and the message today is that together they're stronger. So,
yes.
Sorry, that was...
No problem. My mic is on, yeah? Yes,
yeah.
Cool. How many of you have heard of Elixir or Erlang or have used it? Oh, nice.
Yes.
Quite a few hands. Cool. So let me introduce myself first, and then Francesco will introduce himself. I'm Andrea. I'm from Italy, central Italy, about an hour east of Rome. I've been watching GOTO conferences and talks on YouTube for my whole career, so it's really cool to be here speaking. It's super nice. I don't really get to speak at many non-Elixir Erlang conferences, usually. So it's really nice for me to be able to speak here. So I live in Italy. I live really close to Francesco. We live about maybe an hour from each other. We've never seen each other in Italy. This is like we only see each other at conferences. And I've been in the sort of my role in the Elixir communities that I've been in the Elixir core team for 7 years now. So I've been working with Elixir for a little bit longer, but a lot of this time has been being with the team and helping develop the language. I've also done a bunch of speaking and training and systems architecture. Like I've been a backend developer most of my career, sort of like leaning towards backend. And I co-wrote a book, a bunch of stuff related all to Elixir. So Francesco, you go.
Yeah, I'm Francesco. People can't really place my accent. They look at my name and say, oh, he does sound Italian. Indeed, I am half Italian, half Swedish. Started off in an English school, picking up a really strong British accent. Graduated still in Rome from an American high school with a really strong American accent. Moved to Sweden for a decade, picked up a Swedish accent there. London for 21 years, which kind of killed off the Swedish accent, but never really picked up a British one. You see a hint of it. And now, I've been back in Italy for about 2 years. I've been working with Erlang for 28 years now. This is a picture of my first day as an intern at the computer science laboratory at Ericsson. So it's where the inventors of Erlang kind of created it. It was a research facility looking at studying, kind of computer science. I worked with the R1 release of OTP. For those of you who don't know OTP, it's what inspired Akka. It's the middleware we use for most systems written in Erlang and Elixir. I worked with, helped develop Ericsson's fixed and mobile broadband solutions, and co-authored a few books, teach at Oxford University once a year, concurrency-oriented programming, and also co-founded what has today become Erlang Solutions. And I think what makes me really fortunate is having seen a single programming language turn today into what is an ecosystem of languages. As Andrea says, we live about an hour from each other, but we never meet in Italy. I think it's almost kind of a conference-driven friendship, I think we call it. We last saw each other in Mexico City. This is when we spoke. Prior to that, last year we saw each other in Mountain View, and prior to the pandemic, I think it was San Francisco and Medellin in Colombia. And this is also my first time speaking at GOTO here in Copenhagen, so yeah.
Yeah, so let's just do a little tour of how we came together with these languages that we work on. and we work with. So like many other people, I think, at least the first time that I heard about Erlang, that I like came into contact with Erlang was through this book. Which I think many people know. It's a pretty famous book, but for people who don't know, it's a sort of like a whirlwind tour of 7 different programming languages in the format where you learn a little bit about each of those programming languages through the course of the 7 weeks. That's how it's structured, and it's a sort of like an exploration of different paradigms for programming. So there are languages there like Ruby for object-oriented programming. There's Clojure as Lisp. There's Haskell for statically typed language. There is Prolog for logical programming, and there's also Erlang for this like actor model and processes and concurrency.
And it was in conjunction with the writing of this book that Joe Armstrong, so Erlang's co-inventor, and Bruce Tate started working together. Joe had written the Erlang book for Pragmatic Bookshelf and was helping Bruce with the Erlang chapter. And soon after, it wasn't just Erlang. Every Erlang developer loves Prolog, and he also ended up helping him with the Prolog one as well.
Yeah.
Yeah.
So I didn't really get much into Erlang when I read this book because I was like sort of like a little bit maybe too on the young side of my software development career. So I didn't really, it didn't really click yet. But then I started experimenting. It was my phase where I was experimenting with other languages. Like I tried out, started from C, learned some Java, Python, Ruby, so all sorts of stuff. At some point, I figured out I really loved functional programming. It really clicked with me. I really liked the way of thinking there. And the 2 main big programming languages that were easier to learn back then were Haskell and Clojure, sort of like the 2 schools of thoughts, like statically typed languages, Haskell, or like a dynamic, very meta-programming friendly Lisp one like Clojure. So Haskell was a bit too hard for me back then, I think. I didn't really quite get it. I didn't really quite get the benefit of all these stacks, and it was a little bit hard for someone like sort of new to software development in general. And Clojure just didn't click. I don't know why. Should have, because like it's nice, but like I didn't fall in love with it for some reason. And during this like search for my perfect programming language, for my happy place in the programming language world, I came across Elixir right when it was turning into 1.0, the first like stable release. And I think I was subconsciously looking for a language like this while I was exploring, because I was really looking for a language that would be practical, like functional, yes, but also practical, where you could do stuff like, read a file easily, like do practical stuff, and so like, and also modern language, right? Like a language where you have like modern tooling and developer experience, but also this language was super was based on really super solid foundations, right? So all this sort of clicked together, and Elixir just fell into the into the right spot there. And now it's been almost a decade that I've been working with Elixir. I spent almost 70% of that time being on the core team of Elixir and sort of helping develop the language and the ecosystem. I've been very immersed in the community as well, spoke at a bunch of conferences, and did trainings and all of that, podcasts and whatnot. So I've been in the Beam. The Beam is the virtual machine for Erlang, right? Where Erlang and Elixir run. And I've been in this Beam community for very long now, for like almost my entire programming career. But still, most of the Erlang work that I've done has actually been on Elixir, the Elixir compiler, or maybe tiny patches to Erlang libraries here and there. I've never really done any paid Erlang work. I've never really done any like product development in Erlang, system development in Erlang. I've only used it here and there. I had no commits when we did this talk the first time. I had no commits to Erlang. Now I have one for like documentation update. So it's safe to say that I haven't really like touched the Erlang code base. But even though I've been really focused on Elixir and not really on writing Erlang, most of what I know about OTP, about this framework, and about this paradigm, and about this ecosystem and this virtual machine comes from Erlang resources, right? Like, for example, Francesco's book was a really awesome resource, or Programming Erlang by Joe Armstrong. Those are books about Erlang, really. They don't mention Elixir, but they have so much to teach for Elixir programmers, right? So I consumed a lot of these Erlang resources because back then there were also less Elixir resources than there are today. So I consumed a lot of these. The good news is that the two languages, if you're familiar with both, the two languages are really, really just almost the same. So they are sort of like a different shell, a different presentation layer on top of the exact same data structures, virtual machine, instruction set, like paradigm, standard libraries, like all of it is really quite similar. Especially if you're coming from Elixir to Erlang, it's really just a syntax thing, because Erlang is sort of a subset of Elixir in that you can access all of Erlang's standard library. Elixir is just like a couple of features that they're like protocols that Erlang doesn't, and macros that Erlang doesn't have. But if you're coming from Elixir to Erlang, it's really just a syntax thing. Like the semantics are exactly the same. So, even if it's really easy to learn from Erlang resources, sorry, if you're an Elixir developer, right? And the other way around is also true, because still Elixir has a couple more features here and there that like Erlang doesn't have, but they're really in line with sort of the design philosophy of the Beam and the design philosophy of Erlang. So these two languages are really can be used together and can learn from each other. And I consumed a lot of his Erlang resources exactly because of this reason, because I had access to like a long history of resources being written for this language, which is 30 years old, right? Erlang is like maybe more, but it's like close to 3 decades. Elixir in comparison is about 10 years old, so there's a lot more resources on Erlang. And so we should be able to learn from each other, right? And I think it's really important to educate people in this community to learn from each other's resources and to be able to seamlessly switch between the two languages, right? Because the two languages are most the same thing at the end of the day, right? They're just like slightly different presentation layers. And this means that we can have double the learning resources, right? And there's one thing that Erlang sort of like pushes a little bit more than Elixir, I think, is that it really tries to teach you why things are the way they are, and less, how to do things. So Elixir has a very pragmatic approach a lot of the time, where it teaches you, here's how you do this web application with this framework. And Erlang instead is like, here's why we do things this way, here's why we do this behavior when things crash, and so on and so on. So there's a lot to learn, I think. And Francesco will talk a little bit more about this later on, but for now we'll give him a chance to tell his story coming to Erlang as well.
So I came across Erlang in university. I'd programmed Lisp, Prolog, ML. Ada introduced me to concurrency, and yeah, it was painful. But it was going in and actually comparing productivity gains between AFL, which they taught us in the object-oriented programming course, and Erlang in their parallel course, which did it for me. What we were given, for the two courses, the same assignment. We had a very lazy teacher, and it was we had carrot patches which grew, and then we had rabbits going around in the simulated world eating the carrots. If they had a lot of carrots, they got fat, split in two. If they couldn't find food, the energy level would go down to 0, and they'd die. And then you had wolves going around hunting rabbits, and they had to display intelligence. So if a wolf saw a rabbit, they go in and tell the other wolves within a certain radius, hey, there's food here. And all the wolves would start chasing rabbits. If a rabbit saw a wolf, he'd shout wolf to all the other rabbits in its vicinity and start rushing away. So it was a fun exercise. But what really caught me out was that I did the Erlang exercise first, the Erlang assignment first, and it took me 40 hours to write. Went in the OO programming course and did the AFL exercise, the AFL assignment, together with a friend. And even though we'd already solved the problem once, even though we knew, we reused, I think, a lot of the ideas and the algorithms, it ended up taking us 60 hours, so 3 times longer to solve it in AFL. And that's where I realized that for specific problems, you need to find the right tool for the job rather than the tool at hand. And this is when this is what got me to actually pick up the phone. I called the Ericsson switch and asked to be transferred to Joe Armstrong, Erlang's co-inventor. I had no idea. We'd never met. We'd never been introduced. So called him, and when they put me through, I think This was the 90s, and yeah, I went in and said, "Hey, you want me to speak Swedish, eller ska jag ta det på engelska?" For those of you who don't speak Swedish, it means, "Do you want me to take it in English?" And there was a 3-second silence, followed by a laughter, which those of you who got to know Joe Armstrong will remember and recognize. This loud kind of laughter, and the rest is history. I basically got an internship at the computer science lab, and then moved on to Ericsson, and then founded Erlang Solutions. But yeah, we're digressing right here. So the Elixir programming language, first appeared on my radar in 2012. It was when José Valin, so the creator of Elixir, the inventor of Elixir, gave a public talk. It was the first public talk he gave at an Erlang conference in Krakow in Poland, which we'd organized. I wasn't there, but I got told about we had an office there at the time, so I got told about a local Brazilian developer presenting a Ruby-inspired programming language running on the Beam, so on the Erlang virtual machine. The idea was not new. Tony Arcieri was working with Raya. Raya was a Ruby-inspired, had a Ruby-inspired syntax, was also running on the Beam. This was back in 2008. So, it goes to show the idea was not a bad one. If two people independent of each other come up with the same idea, it's probably an idea worth pursuing. But so José presented Elixir back in 2012. If we go back a little bit, why was Erlang invented? So we're talking late 80s, early 90s. This is a quote from Robert Virding. I'll give you a few seconds to quickly read it. So we were trying to understand how to program the next generation of telecom switches. The result of our research happened to be a programming language. We never set out to invent a programming language. It was just necessary part of the solution of the problem we're trying to solve. So yeah, this is 3 co-inventors and a whole lab actually, which contributed to it. Set out to figure out how do we program the next generation of telco switches. Result happened to be a programming language. And what are telecom switches? They're resilient, so they need to act predictable, especially under heavy load if there's huge user spikes. They have to be scalable, manage millions of users at the same time, show soft real-time properties, and be distributed. For those of you who listened to Jonas Bonner's talk earlier, very similar set of features which he mentioned when talking about akka. So at the time, it was telecom. Today, it's pretty much anything connected to the internet which needs these characteristics. All of a sudden, a million users storm and want to send a WhatsApp message. WhatsApp needs to act predictably. Same with massively multi-user online gaming or streaming or whatnot. So it's Erlang was built for the enterprise. So I think those were back in the days, even before it was released as open source at Ericsson, we had projects consisting of 100+ developers, where you went in, you got told what tools to use. Spending a week integrating, Erlang with their tool chain and workflow was perfectly acceptable. As these were projects which would take hundreds of person years to develop. And these were also systems which, once deployed, would be used for a very, very long time. I mean, just look at 5G networks. They originate from GPRS systems, which were first demoed at the GSM World Congress in Cannes, I believe, in 1998. Eric's nodding, I think he was there as well at the time. So my phone, being assigned an IP address today, is based on a 25-year-old code base. So these are the types of systems we developed and which had to run for a long, long time. Or even just think of code running in tens of thousands of base stations. So it's a very, very different problem to, say, a website, which exists in just a single installation. And I mentioned websites here, knowing what we know today. So we tried very, very hard to get Erlang into the web space because web server needs to act predictably. All of a sudden, back in the days, you ended up on Slashdot. Servers went down because you had tens of thousands of users going in and looking at your website. Erlang Web Service could handle these spikes very, very gracefully. And so, we were trying to get Erlang into the web space. We had lots of frameworks, just to mention, I was looking them up yesterday: Early Web, Chicago Boss, Nitrogen, to Erlang Web, Zotonic, and all of them really went in and outperformed Ruby on Rails. They're all based on a set of Erlang web servers. We had Mistletoe, Yaws, Cowboy, Mocky Web. And what all of these web servers had in common is that they all outperformed Apache, big time. Not only, they then had races internally over which of these Erlang web servers was the most scalable, which meant that they really, really scaled. And researching this talk, I even went in and found, we call this the LYME stack, the Linux, Yaws, Mnesia, and Erlang stack. And I even found it has its own Wikipedia page. Never made it big time. I think most of the websites we did in the LYME stack was just operation and maintenance for telco products. So these are things which didn't have to be scalable, didn't have to be reliable. The point with the LYME stack is they ran on Linux. They used Yaws, which was yet another web server, stands for yet another web server, was released as open source by a company which got acquired by Nortel Networks. Mnesia was a distributed Erlang database. It was a distributed key value store, which was open source, which has been around since the mid-90s and was open source in '98. So probably the first, I guess, jokingly, NoSQL database out there, which was made available to the masses. And when you put all this together, what made it really incredible was that it all ran in the same memory space. Your web server would send a request to some business logic written in Erlang. So your Erlang web server received the HTTP request. It would send the request to a function which was in Erlang in the same VM, which would then do a lookup in a database written in Erlang running on the same virtual machine. So incredibly fast. We were serving dynamic web pages in sub-milliseconds. And this was actually faster than caching static pages in, say, Redis. But as mentioned, adoption was really, really minimal. And the reason is, to use any of these frameworks, you needed a degree in computer science to use it. And it's great if you're Amazon or Google, or you need to deploy an API at scale, but completely useless if you're a small e-commerce site, with a few dozen transactions per hour. The accessibility of these frameworks just didn't make sense for someone who had a simple problem to solve. And looking at the success of Elixir today in the web space, we realized that our failure was not focusing on the user experience, not focusing on the documentation, the tooling, and the ease of use. Instead, what we did is we focused on what we knew best, back then, which was building distributed soft real-time systems with requirements of scalability and availability. And that's what, so we might have had the fastest and most scalable frameworks, but if you did not need scale and you did not need reliability, or didn't think you needed scale or reliability, why pick an esoteric language not created for the web? And Andrea told us he first heard of Erlang in 2013 when reading 7 languages in 7 weeks. Well, that's also when Erlang got on Jose Valin's radar. What was his goal when inventing a language? And this is one of the questions I ask any language inventor. What problem were you trying to solve? And this was, Jose's reply.
Yeah, so the quote is, I wanted to bring the power of Erlang and the Beam to other communities of programmers, starting with the web, but then moving on to other domains. So Elixir was born to sort of doing exactly that, right? And as Francesco said, they found out about Erlang the same way I did, which is through this book, 7 Languages in 7 Weeks. And his background was in Ruby and in web development. So it was he was a member of the Rails core team, the web framework. And this gave him a lot of knowledge about the web space, right? About building web applications and the web framework space and all of that. But he moved away from Ruby sort of in search of something that would possibly be a better fit for building modern web applications, modern, performant, scalable, and reliable web applications. And he said, that when he found, he said this over and over, but he said that when he found Erlang, he liked everything he saw, but he hated what he didn't see, right? So this sort of speaks to this, to what Francesco was saying, that Erlang was like, it had everything just I wanted in a language that would be fit for these use cases, for the web, for scalability, for reliability, but it was not accessible to everyone, right? Especially not to this big community of Ruby developers who were used to very nice developer experience, a very ergonomic language, a very clear and expressive language, right? So when he started working on Elixir, that's exactly what he wanted to do, sort of merge the two ideas of a language that's friendly, that's modern, has great developer experience, has great developer tooling, but also leverages this incredible virtual machine with these incredible properties that is the Beam, right? So and so he tried to merge the two in order to attract developers that would be, that would come from, for example, from Ruby and like expect that ergonomics and expect that niceness of the language, and but also bring them these features from the Beam, from reliability and scalability and all of this stuff. And part of this effort was meant building a modern language with modern features. So we had to have a lot of focus on developer experience. This comes from Ruby, but like also from Node, for example. Like Node sort of like changed the shape of how you're supposed to have colors on the terminal and stuff like that, right? So like a nice developer experience. It also meant being able to build a state-of-the-art macro system. So Elixir has it's a home iconic, so it's like the AST of Elixir is just Elixir term, so it's very easy to manipulate the AST. We also had to have first-class documentation, first-class testing tools, so all the stuff that you would expect from a modern language, right? And the cool thing is that when Elixir 1.0 came out, that's exactly what it actually had. So it had a completely extensible modern build tool, which is called Mix, which is sort of like be able to run tasks and compile, like run as a compiler and run tests and generate documentation and all this sort of stuff. When it came out, it had package management out of the box. So we have a package manager called hex.pm, where Erlang and Elixir packages are hosted, and this worked right out of the gate on 1.0. We had a tool for generating HTML documentation from inline comments called xdoc. So this was all part of 1.0. We had a really powerful and simple built-in test framework called XUnit that was shipping with language, logger integration. All this stuff was part of 1.0 for Elixir. So, and these are not new things, right? These are all things that Erlang had for a while.
So we've had all of these tools, but we weren't allowed to use them. It was really, really hard to get enterprise to adopt Erlang tools. They were not documented, or they were not well integrated in the best of ways. And as Erlang was being developed separately with very little input from the community, it was also hard to integrate these tools into the workflow with libraries or even the language itself. I mean, just to give an example, not related to Erlang, but I was on a project at Ericsson, and we weren't allowed to use Gmake, back in the 90s, because it was you couldn't buy support for Gmake. So yeah, how did we get around it? Well, we downloaded Gmake, and then we just renamed it Make, and and no one ever noticed. But but that was the rules and guidelines that we had to follow. So even though we had tools similar to Mix, we had a package manager in the mid 2000s. There was no adoption because we just couldn't get and agree on a single approach and way of doing things. And when Jose started, he was able to start with a clean slate and saying, this is what we do and this is how we do it. And also, the times have changed.
Yeah, and also I think it comes from his experience in open source and in being a central part of a big open source community and open source product like Ruby on Rails. Because in Erlang, as Francesco said earlier, people were just solving problems. Like you were out there writing a web server because you had the need for a very performant web server for your use case. So you would write a web server, and then you wouldn't worry about like getting it adopted and something and all that comes after that, right? Because like people were solving problems, and instead Jose was able to sort of like bring together this culture of like building really high performance stuff and reliable stuff from Erlang, but bring the open source experience and the developer experience that he had from Ruby on Rails, and sort of bring them together. So he was able to start Elixir in a way where the whole language was integrated. You had out of the box, the build tool, the testing tool, all of the parts of the sort of the developer experience were together in the language, right?
Just to add, I mean, Erlang got released as open source in 1998. So it was the year the term open source got coined. And in Ericsson's view, open source means here's the source, it's open, don't bother us. And that was the view for a long, long time. No one knew what open source meant. Management didn't know, and it's something which scared them. It took a long time to convince them to release it as open source, and released under a very obscure license. And then it took even longer to convince them to change the license to an Apache license.
Yeah. So this is definitely different from the way Elixir started, which was like completely, the way that also something like Rails was running, right? Very open source, very open to contributions. And the nice thing that got Elixir off the ground, I think, pretty quickly as well, was that Elixir had a really nice ecosystem right out of the gate, right? So when Elixir was built, at the same time there was a web framework being built, Phoenix, right? And a database mapping layer, Acto. So these were all released sort of 1.0 around the time that Elixir became 1.0. So if you were an early adopter of Elixir, you didn't have a really bad experience at all, especially if by early you mean like maybe a year or two after it was started, because like initially it was very young, but like in a couple of years already you were able to get the language with like really good documentation, a testing tool, a build tool. You had a database mapping layer, you have a web framework, and you just relied on something like Postgres. You could build a web app with a very new language. You were productive from the get-go, right? And as a community, Elixir, because of this, Elixir sort of started building stuff in layers. So you had you had the layer of your application, and under the layer of your application, you would have Acto to talk to your database, and you wouldn't worry about that because it's like a tool that's built for us, for you, right? And you had a web framework to serve web stuff, to serve HTTP requests that was built for you, right? So you could really already, from early on, get things together, piece things together, and do sort of Lego things, and like make something that worked, and worry about your business logic, and not worry about building the support that you need to run something like this, right? But the problem with layers of abstraction like this is that they have downsides too, right? Because, for example, how many of the people in the Beam community know the inner workings of something like Acto or Phoenix, like a framework like those? Or, for example, how many of us found bugs or submitted a patch to which enhanced performance or something like this, did like sort of like deeper analysis work or like performance work? We're lucky because today like performance is like a little bit easier to manage because computers are generally fast. But we as Elixir people sort of like benefit. We didn't really have to do that because Erlang people had been doing that for 20 years. They've been optimizing compilers, they've been optimizing the runtime, the data structures. Everything was like really the result of 20 years of work that we could leverage, right? You go.
So yeah, we've always gone in and worked in layers in the Erlang world, and abstraction layers are the best way both to add and to hide complexity, whilst enhancing programmer productivity. And Andrea said we added performance in the early days, and we had the very first systems we were writing required granular control over everything we did. We were implementing telephony switches on single board computers with 16 meg of RAM, and every CPU cycle, every memory byte was accounted for. You could not rely on dependencies which you just pulled in from a package manager. You needed to know how everything under the hood worked and have control of it with the knowledge and the ability to optimize if and when it was necessary. As an example, we're using flash memory, which meant that we could only write something a limited number of times on the drives, on disk. So if you look at the flags when you start off the Beam virtual machine, there are some which allow you to load code across the network. And this was done to reduce the overwriting of flash memory. And we used the flash memory only to bootstrap and download the core of the switch, which didn't change. And the rest of the code base was downloaded across the network at startup and just stored in memory. So these were the different backgrounds and different type of problems and challenges we came from. And so in the Erlang world, I think another big difference is that we solve systems in a bottom-up approach. We take the problems which we perceive as hard, isolate them, and get them to work. Isolating makes it easy, and failing on a single component means that the whole project fails. So you want to fail early in case you're going to have issues. So only when all of the components work and we show that we've solved these hard problems, that's when we go in and integrate everything. So at heart, we are back-end engineers, and always used to ask ourselves jokingly, why do you need a good-looking user interface or UI when your critical components don't work? It's nice to have a pretty GUI, but if your system doesn't work, it doesn't work. So failing to implement this critical component would mean that the system does not work.
Yeah, and Elixir sort of takes the opposite. It always took the opposite approach. I think it naturally tends to encourage this top-down approach because it comes from the tooling and the package manager and the ecosystem, right? Because, for example, Phoenix was out, Ecto were out right at the start, right? So you never had to sort of build these components yourself. And on the web, for example, you need to visualize stuff that you're building very early on. So you can't take this approach where you solve like a little small part of the core logic and then you start building layers on top. Often you need to actually start to visualize stuff right away, or you need to build user interactions and stuff like that. And then we had this really excellent package manager that made it really easy to use packages, right? So it made it really easy for people to just put a package out there that connects to Redis or the Redis driver or Postgres driver or an API, like a GitHub API SDK or something like that. And you could just use them very easily. So you could focus on like picking the tools that you needed and focusing on the business logic, right? So like taking the little building blocks and building applications out of those. And these things sort of led Elixir to being into being a really good language for prototyping as well, right? Because you had this sort of similar experience that you would have with Ruby or with Node, even if maybe Node, for example, takes it a little bit to an extreme, but like that's the idea, right? Where you have like all these building blocks that you put together and you just build the business logic of your application, right? So for example, recent example that you have of these that have been, popping up in the Elixir community are things like Livebook. I don't know if you've ever heard about Livebook, but it's like interactive code notebooks for Elixir. And another one is Bumblebee, which is a framework for like running machine learning models essentially. And those things like sort of follow this exact line of things being built for you, and you just have to piece them together and build quick prototypes and have like fast feedback loops and all of that with just like a few button clicks. You just download this library, you set up this notebook, and everything's done for you. However, once things start to increase in complexity, usually you have to go top down and start like going down the abstraction layer and maybe replace things that have not been scaling very well or that can't be tweaked enough for your use case, and you have to tailor them for your own use case, so it's a little bit harder to, you have to go top down and sort of like start to modify the components in order to make things work for your use case, right? And one good and bad thing at the same time is that Elixir and the ecosystem, they really do a good job at hiding all of the stuff that Francesco was talking about Erlang, right? They hide all the complexity of OTP. They hide a lot of these, process. They do a lot of abstractions on processes so that you don't really see this stuff, right? And many times in my career, I've been asked by people in the Elixir community, how do I learn to use a Gen server, for example? How do I learn to use this specific OTP abstraction because I don't have a chance to? And it makes sense because if you write Phoenix applications that use Ecto as your database driver, you don't really interact with the things. They power the whole thing. You're already using OTP all the way down, but you're not really touching it. You're just taking advantage of the reliability and the scalability and the concurrency, but you don't have really to write any of this code, right?
It's a really interesting thing. Basically, by sequential web servers are massively concurrent activity. Every user is a process, but with Phoenix, just by knowing sequential code, you're able to deploy web servers, which can have up to 2 million WebSockets open simultaneously, without understanding the concurrency model behind it, and without having to worry about it, because it does it all for you.
Yeah, it's only when you have to like really tweak the system to your use case or to your performance needs that you have to go down. Otherwise, everything is really, it's a really nice abstraction layer that you can use. And it's an abstraction layer on top of these Erlang things that are there. They're the ones powering all the whole thing. It's just maybe an ergonomics thing. That was why Elixir has this appeal to people, right?
10 minutes.
Yeah, and the main message that I like to give here from Elixir and from the perspective of someone in the Elixir community is to not reinvent the wheel. And I'll tell you a little bit of a small story about that, a short story. I watched this YouTube sort of documentary essay recently, which is called "Why It Took 200,000 Years to Invent the Wheel," and it was really interesting. So what happened in the video is that they gave a couple of people like us, like normal people, they gave them some wood sticks and like little wood parts and glue, and they told them go invent like a toy that has wheels that can roll around, right? And like you would imagine it's easy, but they were like stuck there a long time trying to figure out how to rotate the axis on the thing, on the wheel, and how the wheels like parallel, how do I make them parallel, how doesn't it fall, why doesn't it fall? A lot of stuff to be concerned about, right? And I think most of us, when we hear the expression reinventing the wheel, we associate it with redoing something that's already been done over and over again, so there's no point in doing it ourselves, right? And that's part of it, but the other part is, I think, that the wheel is just very hard to reinvent, right? Even when we think we know pretty well how wheels work, I think we tend to underestimate a lot what goes into making them work, right? Because we had years and years and years of time to perfect something like the wheel, so why would we think that inventing it in the first place was somewhat easy? Like, why did it come through so many time that the humanity was around, and then they invented the wheel? It's probably like it's not maybe the most intuitive, super intuitive thing that you can get, right? And so it was not just under their nose of ancient people inventing the wheel. It's just that it takes time to perfect this sort of stuff. And so here now I'm saying let's not reinvent the wheel, but not because the wheel was already invented, not because it's just there, but let's not reinvent the wheel because it's really hard to reinvent, right? Erlang and the Beam have been around long enough that they had to iron so many issues and do so many performance improvements and performance tweaks and all of this stuff. And those are, why throw those away? It's not about reinventing the wheel so that we do it the same way. It's about taking the vendor something that was really hard to solve in the first place, right? And Francesco will tell us a little bit more about what else.
Brilliant YouTube video. I really recommend you look at it.
Oh, it's mine.
Yeah.
Sorry. So the detail, the some of those details are that the Beam sort of figured out already are the VM, for example, right? Like the scheduling, the concurrency, the resiliency, the garbage collection of the virtual machine, the distribution. We have clustering built into Erlang. We have release handling. We have tracing. We have compiler optimizations. We have hot code upgrades. We have so many things that have been solved by Erlang. Right?
Soft real time.
Soft real time.
The soft real time properties are incredible.
Yeah.
Really optimized to make sure that no one process goes in and hogs too much CPU power.
Exactly. Yeah. Exactly. So and these are things that Erlang solved quite a bit ago, right? And this is not to discourage people from trying new things. And there are Elixir is an example of that. Elixir really brought value, I think, to the Erlang community, right? And now there's Gleam, for example, if you've heard of that. It's like a statically typed language on the Beam that's gaining a bunch of traction. So there's people experimenting, but all of these things are taking advantage of what's already there. Like Gleam, for example, using Hex to publish packages, right? So instead of focusing on the problems that are already being solved, that already are in a really good state and that have already been maintained and cared for many, many years, I try to think about the problems that all, the Beam community shares. So for example, problems that we can all benefit from, right? And I think Francesco will tell us.
So going back to solved problems, WhatsApp, which many of you might know or might not know, is all written in Erlang, was focused, their focus when they were creating WhatsApp in the early days was reduce hardware and operational costs. And they achieved this by trying to cram as many users as possible on a single machine. And the goal was achieving 1 million TCP/IP connection, which they hit in 2011. And January 2012, this blog post comes out, a very Californian. 1 million is so 2011. It's so last year. And they went in and announced that they achieved 2 million TCP/IP connections. And after that, they even peaked sometimes at 3 million. And they did that by fine-tuning FreeBSD, by optimizing it, and by forking the beam. For them, less hardware means less parts which can go wrong, lower infrastructure costs, which in turn map to lower operational costs. Now this was before WhatsApp got sold to Facebook, and before they even went in and raised the first round of VC money. The changes they did got integrated into mainstream operating systems and into the beam. And 2015, Phoenix, so the web framework in Elixir, announced that on standard AWS hardware, they'd managed to open 2 million TCP/IP connections, 2 million WebSockets simultaneously open on a single machine. And we're talking about 8 years ago on standard AWS hardware. So in Phoenix, every WebSocket is a process. It receives a request, handles it. So yeah, the concurrency is the main building block. And and this brings me back to this slide, which is a study Joe Armstrong did in probably 2003, 2004, which shows in red the yours web server I was talking about earlier. And we've got the throughput in kilobytes per second in the vertical axis, and the number of simultaneously open connections. And we see here that up to 80,000 TCP/IP connections, 80,000 simultaneous connections, the throughput remained constant. And this is what I talk about, making sure that each process basically has soft real-time properties and doesn't go in and starve other processes. Not only that, there's no degradation of throughput the more processes you add. Comparing it to Apache with or without threads, which are the green and the blue ones, which at 8,000 back then kind of ground to a halt. And indeed, you could have optimized Apache. You could have probably increased that throughput, but not to the same levels. And you see quickly how fast it downgrades. And we're comparing apples and oranges here. Because in Erlang, we've got processes handling the TCP/IP connections, lightweight processes. Apache, I think, uses threads at the time. So, it's despite that, no one actually went in and used yours in anger. And I'm shooting myself now, but why did no one think about just patching yours as a standalone web server, to go in and start challenging Apache? You wouldn't have drawn everything in the same memory space, but it sure would have helped. And these are Joe Armstrong's tenets. So the world's concurrent. Things in the world don't share data. Things communicate with messages, and things fail. And these tenets, or a tenet is a belief. And what they did is going in and model a programming language around these ideas. It's a natural way of thinking. And use processes to model your programs. They'll conceptually go in and run in parallel. They will not share memory with each other. And they will communicate by sharing messages. And things can fail. It's a very natural way of thinking. We're all kind of concurrent beings. We don't share brains. And we're communicating with message passing. I'm sending out a message to you all. You take in, whatever, you each store a copy of it. If you don't find it interesting, you chuck it away. And you free the memory for other things. So, and most important, things fail. Sometimes they recover, sometimes they don't. So it's so concurrency, going back, is the main building block in Erlang Elixir. But what has attracted many developers and many adopters to the ecosystem is that when using these frameworks and libraries like Phoenix and Ecto, you're productive without having to learn concurrency. It's all hidden from view. So all you need to do is focus on the APIs and focus on the sequential code or the Ecto queries. And this we never realized, feels familiar to folks with diverse backgrounds. It didn't feel familiar to us with a computer science degree hacking away with Erlang, but for someone coming from a web development background, it felt like home. And this is why, I think Elixir is, taking off the way it does. In Erlang, the level of scale and reliability mean that you need, of the problems we solve mean that you need to be in full control. You don't need to be in full control when you're developing a website which is already highly performant and highly efficient. I mean, think of, Phoenix with 2 million TCP/IP connections. You don't worry about it. So, working with Joe Armstrong, back in 1995, he told me, Erlang won't be around forever. Something better will come along someday. And then, and people will start using it, and they'll stop using Erlang. So I started to wait and wait and wait. At all the conferences, we arrange a lot of conferences in the Erlang community. We always went in and invited other language inventors with a very open mind. I think we had Martin Odersky, Simon Peyton-Jones, Alan Kay, Don Syme, Rich Hickey, Guido van Rossum, Larry Wall, to mention a few of some of these right minds, and they learned a lot from us. We learned a lot from them. And we started discovering more and more languages being ported into the Beam. And as they started being ported to the Beam, just like Jose was invited to one of our events, we welcomed them as well. And today, I think there are over 35 languages running on the Beam in the ecosystem. Erlang and Elixir and Lisp-flavored Erlang maybe being the ones which are most known, but we're seeing a big push for statically typed languages. Alpaca, Fez, Alchemy, and Louis Pilford, is working on Gleam. So, and I think Gleam, is something to look into and keep an eye out for. With the Beam moving to more secure IoT devices, I think static typing will play a very, very important role in helping achieve the security, as it reduces kind of the surface, of attack greatly. So, keep an eye on the space and be open-minded, as Erlang and Elixir will not be around forever. So, if I could travel back in time, what would I tell this guy right here? Get a decent haircut. This was a student. I couldn't afford haircuts back then, but I would have never guessed that 20 years later I would still be working with Erlang, and that this picture would still be flashed on screens all over the world. Had I been able to travel back in time and speak to this guy, I wouldn't have believed the person telling me that.
Yeah, I think that's a good conclusion. We're stronger together.
Yep. So, and when we talk about communities, it's not just Erlang or Elixir or other Beam languages. It's about all the other languages in the ecosystem, all the other languages out there. Some are a bad reinvention of the wheel. Many aren't. They'll always bring new ideas to the table, which will help teach, learn, and inspire us, to move forward. So, this is it. Thank you.